Good morning. So today we are going to discuss about the factors which is affecting the drug metabolism. So drug metabolism is nothing but the breakdown of the drug molecule in the living organisms by the means of various enzymatic systems. So drug molecules can also be called as xenobiotics. Xenobiotics are nothing but the foreign compounds. Okay, so these foreign compounds, they undergo metabolism in the body and thereby they convert into non-toxic compounds. So this xenobiotic metabolism or the metabolism of the foreign compounds such as uh, drugs is also known as biotransformation. It is also known as detoxification, hence since these metabolic pathways, it will convert the drug into a non-toxic form. So thereby it is also called as the detoxification process. So the rate of metabolism, it determines the duration and the intensity of a drug's pharmacological action. So this when you take this drug metabolism, it can be divided into different phases, like phase 1 and phase 2. So in phase 1, again, there are different metabolic reactions like oxidation, reduction, hydrolysis, etc. So there are various enzymes which is involved in the drug metabolism. So if you take in oxidation, the cytochrome P450 is the drug enzyme which is involved in the metabolism of the drugs. So these modified compounds, that is the drugs which undergo phase 1 metabolism, they are conjugated to polar compounds in phase 2 reaction. So there are various phase 2 reactions like glucuronic acid conjugation, sulfate conjugation, amino acid conjugation, etc. So these particular drug molecules, they are conjugated by the various conjugating molecules, and thereby they convert the drug which is lipophilic into the hydrophilic nature, and these hydrophilic compounds, they can be readily excreted from our body. The sites of drug biotransformation. So when you take, there are various sites in a body where the metabolism or the biotransformation can take place. So the smooth endoplasmic reticulum of the liver cell is the primary organ of drug metabolism, even though uh, the uh, the even though every biological tissue has some ability to metabolize the drug. So when you take liver, it has a higher concentration of most of the metabolizing enzymes, and thereby liver is the major organ. So liver consists of a pool of enzymes which is required for the metabolism. So because of that, the major metabolic reactions, it takes place in the liver. The other side of drug metabolism includes the GIT, lungs, kidney, skin, the epithelial cells, brain, etc. So these are the different sites where the drug metabolism can be taking place. The factors affecting drug metabolism. So we have the chemical factors, biological factors, and the physicochemical factors. The chemical factors are nothing but enzyme induction and enzyme inhibition. In biological factors, we have age, diet, gender variation, species variation, variation based upon the strain. Then there are also certain altered physiological factors which can affect the metabolism, and the stereochemical aspects also. So when we come to the chemical factors, the first factor is enzyme induction. So enzyme induction is nothing but the process by which the enzymes which are involved in the metabolism, their rate is being induced either by drugs or some other agents. Okay, so the process of increased drug metabolizing ability of enzymes by several drugs and other chemicals, that is called as enzyme induction. And those compounds which will induce the enzyme, they are called as the enzyme inducers. So this in enzyme induction may be due to different mechanisms. One is like the increase in the liver or the blood flow to the liver is being increased. In that case, there will be induction of the enzyme, and increase in the total as well as the microsomal protein content can lead to induction. Then the increased stability of the enzyme, that will also lead to induction. So there are various consequences of enzyme induction. One is decrease in the pharmacological activity of the drug, and another is increased activity where the metabolites are active. That is the consequences because of this enzyme induction. So enzyme induction is nothing but a process in which the drug induces or enhances the enzymes which is involved in the drug metabolism. So for example, if you take one example is rifampicin. So this rifampicin, if it's being it will induce the metabolism of oral contraceptives. So because of that, what will happen is it will decrease the effectiveness of the contraceptives, and thereby it leads to pregnancy. Similarly, phenobarbital, the CNS drug, if it is being administered to patients who are taking warfarin, the anticoagulant drug, it will induce the metabolism of warfarin, and so because of that, it will lead to therapeutic failure. Okay. Similarly, autoinduction. Autoinduction is nothing but the process by which a drug induces the metabolism of other drugs as well as its own. That is called as auto-induction. It will induce the metabolism of its own as well as other drugs. For example, is carbamazepine, the anti-epileptic drug. So it will act as an auto-inducer. Okay, so these are all some of the examples of enzyme induction. Similarly, you can see here it is shown rifampicin. It will induce the oral contraceptive steroids, and thereby their metabolism will be rapid. And this rapid metabolism of these drugs, it will lead to ineffectiveness of the drug. Similarly, if you take acetaminophen, its metabolism is being induced by ethanol. Okay, ethanol, it induces the metabolism, and that is mainly it will induce the enzymes which is involved in the metabolism. So this particular drug, it will be rapidly metabolized. Acetaminophen is nothing but paracetamol. So it will undergo rapid metabolism, and thereby it will get converted to this metabolite. Next factor is enzyme inhibition. So a decrease in the drug metabolizing ability of an enzyme is called as enzyme inhibition. Okay, so the enzyme inhibitors are nothing but the drugs which will inhibit the enzymes which are involved in the drug metabolism. So this may be either direct inhibition or it may be indirect inhibition. So direct inhibition is by interaction at the enzyme site, and thereby there will be a change in the enzyme activity. So these are the different mechanisms by which direct inhibition takes place. One is competitive inhibition. So competitive inhibition, how it takes place is that these drugs, they will be competing with a similar site on the enzyme. So because of that, there will be competitive binding to the receptor, and thereby the competitive inhibition will be taking place. Non-competitive inhibition means it occurs when the structurally unrelated agent, it will interact with the enzyme, and thereby it will prevent the metabolism of the drugs. Then product inhibition is the metabolic product, it will compete with the substrate for the same enzyme. So thereby it will be leading to inhibition. So a drug, it will undergo metabolism, and that metabolic product, it will compete with the substrate for the same enzyme. Then the second type of inhibition is indirect inhibition. It is caused by one of the following mechanism. One is repression. It may be due to fall in the rate of enzyme synthesis, or the rate of enzyme degradation is more. The second is due to altered physiology. That may be due to some nutritional deficiency, or it may be due to some hormonal imbalance. So because of that, the level of the inhibition will be taking place, or level of enzymes will be less. So these are all some of the examples. One is terfenadine. Okay, so this particular drug, this is an antihistaminic drug. It will undergo metabolism in the presence of the cytochrome enzyme, and thereby it will form the active antihistamine. So this erythromycin or ketoconazole, this particular drug, it will inhibit the metabolism of terfenadine, that is by inhibiting the enzyme which is being involved. So so because of that, what will happen is the this particular metabolite, the active antihistaminic agent, will not be formed. So enzyme inhibition is more important clinically than enzyme induction, especially for the drugs with a narrow therapeutic index. For example, if you take anticoagulants, anti-epileptic drugs, then hypoglycemic drugs, for all these drugs, enzyme inhibition is very important parameter. So these are all some of the examples of enzyme inhibition. Certain drugs which will inhibit the cytochrome P450. So cytochrome P450 is the oxidative enzymes, the family of enzymes which mainly carry out the oxidative biotransformations. So examples are amiodarone, cimetidine, then various antifungal azoles like ketoconazole, then the macrolide antibiotics like erythromycin, then the antibiotic chloramphenicol, ritonavir, then grapefruit juice. So these are all some of the agents or drugs which will inhibit the oxidative enzyme. So most of the drugs, they will be undergoing oxidative biotransformation in the presence of cytochrome P450. So these drugs, they have the capability to inhibit the cytochrome P450 enzymes. The second factor is age, the biological factor, that is age. So the rate of drug metabolism, it varies in the different age groups. So that is mainly because of the variation in the enzyme content, the enzyme activity, and hemodynamics. So when you take the age group, so we can divide into newborns, or infants, then adult, and old age or elderly kind. Okay, so when you take in neonates, that is up to 2 months, and in infants, that is 2 months to 1 year, so the microsomal enzyme system will not be fully developed in the newborn babies as well as in the infants. So because of that, what will happen is many of the drugs, they will undergo slow metabolism in neonates or infants. For example, if you take caffeine, if you are giving caffeine for a newborn or a kid and an adult, you can see the variation in the metabolic rate. So caffeine, it has a half-life of 4 days in neonates in comparison to 4 hours in adults. Okay, then similarly children, okay, children and the year old, like 12 year, okay, kids and adults and all, if you see, they metabolize several drugs much more rapidly. Okay, so the rate of metabolism, it will be maximum in 6 months, between 6 months and 12 years. So uh, they require larger dose of the drug. Whereas, so that's same in the case of adults also, because in adults also the enzyme levels will be good, and so because of that, the rate of metabolism will be good in adulthood also. Whereas when you take in elderly people, the liver size will be reduced, the microsomal enzyme activity will be decreased, and the hepatic blood flow is also less. That is because of reduced cardiac output. So this will contribute to decreased level of metabolism in the elderly people. So for example, if you take chlormethazole, it shows a high bioavailability within the elderly. Therefore, they require a low dose. So, like that, the rate of metabolism it varies in the different age groups. So now we come to the biological factors, that is age. Biological factors, that is age. In neonates and infants up to 1 year, the microsomal enzyme system is not fully developed, and thereby many drugs are being metabolized slowly in the neonates or in infants. So the half-life of in caffeine in neonates it is 4 days, whereas in adults it is 4 hours. So whereas in this is the data in the adult as well as the little older group. Okay, so the rate of metabolism it will reach maximum because the level of enzymes will be good, and they require larger dose. Whereas in elderly people, if you see, because of the reduced liver size, reduced hepatic blood flow, or reduced enzyme activity, there will be decreased metabolic rate when you compare with that of adults. Okay, so in infants, the microsomal enzyme system is not fully developed. So if you take certain enzymes, that is the glucuronide transferase enzyme, the levels will be very less in infants. Similarly, certain other enzyme levels also will be very less in newborns as well as in infants. So because of that, whichever drug which will undergo glucuronide conjugation, that pathway will not take place in newborns and kids. For example, if you take the chloramphenicol antibiotic, it does not have great efficacy in infants. So, if you're giving chloramphenicol antibiotic for the newborn babies or infants, it will lead to gray baby syndrome. Okay, so the baby will become cyanosed. That means blood circulation will be less. The body will become bluish, then hypothermic, flaccid, and gray in color. Shock and even death might occur if toxic level of this antibiotic is accumulated. So this antibiotic chloramphenicol it mainly undergoes metabolism by glucuronide conjugation. So the levels of glucuronide transferase enzyme is very less in newborns, and because of that, this particular drug cannot be metabolized. Similarly, diazepam it may leads in floppy baby syndrome. So floppy baby syndrome is also a neuromuscular disorder. So it can lead to many disabilities in children. Next is diet. So the enzyme content and activity of the enzyme it is altered by a number of dietary compounds. So if you take the low protein diet, it will decrease, and whereas high protein diet, it will increase the increase. Okay, that is the enzyme synthesis is promoted by protein diet, and also it will raise the level of amino acid. So amino acid conjugation is one of the pathway for drug metabolism. So then if you take fat-free diet, it will depress the cytochrome P450 level, since phospholipids, which are the important components of microsomes, they will become deficient. Similarly, if you take grapefruit, it will inhibit the metabolism of many drugs, and it will improve their oral bioavailability. Then the dietary deficiency of vitamins like vitamin A, B2, B3, C, E, etc., and certain minerals like calcium, iron, magnesium, zinc, etc., it can retard the metabolic activity of enzyme. Then when you are starving or starvation, it will result in decreased amount of glucuronides formed than under normal conditions. So like this, based upon the diet also, the rate of metabolism can be varied. Then gender variation. Gender variation is when you take male and female, the level of metabolism rate differs in males and females. So certain drugs like aspirin and all, they are rapidly metabolized in males when compared to females. So this variation in the metabolism. It is being observed following puberty. So the rate of metabolism, the variation in the rate of metabolism, it is mainly due to the drug metabolism, mainly due to the male sex hormones androgens. So in males the metabolism rate is fast, so that is mainly because of the male sex hormone androgens, which are enzyme inducers. Okay, so thereby various drugs like benzodiazepines uh, and aspirin, etc., nicotine, etc., they undergo metabolism in men faster when you compare with that of females. And similarly, women who are on contraceptive pills, they metabolize a number of drugs at a slower rate. Then species variation. Species is nothing but the rate of metabolism. It varies from one species to the other. Species difference. It has been observed in both phase 1 and phase 2 reaction. In phase 1 reaction, both qualitative and quantitative variation in the enzyme levels have been observed. The qualitative difference among species, it generally results from the presence or absence of specific enzyme in those species. The quantitative difference is mainly because of the variation in the amount as well as the localization of enzymes, uh, and the amount of natural inhibitors and the competition of enzymes for specific substrate. So if you take amphetamine and ephedrine are predominantly metabolized by oxidative deamination, whereas in rats, aromatic oxidation is the major route. Okay, so species. So humans are one species. Similarly, rats are another species. So when you see the rate of metabolism of the drug amphetamine and ephedrine, they are metabolized